What if the earthquake that just rattled your city wasn't an isolated event, but a ripple effect from thousands of miles away? Prepare to have your understanding of our planet shaken as we uncover the hidden threads connecting the Pacific Plate's deep movements to seismic activity across the entire globe. You won't believe how interconnected our world truly is. Deep beneath the surface, the Pacific Plate's movements are being meticulously traced, revealing surprising connections to seismic activity across the globe. Audiences will be captivated as the intricate network of geological forces shaping our planet is unveiled. Hey friend, imagine this. You're sipping coffee in your kitchen, scrolling through the news, and bam! Another quake hits somewhere far off like Japan or Chile. You might think, that's rough, but it's got nothing to do with me here in, say, California or even Europe. But what if I told you that the ground under your feet is part of a vast living puzzle where one piece's twitch can send shockwaves literally around the world? That's the wild reality of the Pacific Plate. This colossal slab of Earth's crust that's not just big, but the biggest player in the game of global seismicity. Let's dive in, like we're chatting over a campfire, because this stuff is too fascinating to treat like a dry lecture. First off, let's meet the star of the show, the Pacific Plate. Picture a giant sprawling sheet under the Pacific Ocean, covering a whopping 103 million square kilometers. That's bigger than all the world's continents combined if you squish them together. It's not some lazy, static hunk of rock. Oh no, this thing is alive with motion. It's the largest tectonic plate on Earth, and it's hustling along at speeds up to 11 centimeters per year in places, which might sound snail-like. But over geological time, that's like a freight train reshaping the planet. It's mostly oceanic crust, dense and basaltic, with bits of continental stuff snuck in, like New Zealand or parts of California. But here's the kicker. It's the fastest-moving major plate out there, sliding northwest relative to its neighbors, driven by the churning convection in Earth's mantle below. Now, to get why this matters, we gotta zoom out to plate tectonics, the grand theory that explains how our world ticks. Earth's outer shell, the lithosphere, isn't one solid piece. It's cracked into about 15 major plates, like a cracked eggshell floating on a gooey asthenosphere. These plates are constantly grinding, pulling apart, smashing together, or sliding past each other. The Pacific Plate? It's a master of all trades. Along its edges, it dives under continents in subduction zones, spreads apart at mid-ocean ridges like the East Pacific Rise, and scrapes sideways at transform faults, like the infamous San Andreas in California. This isn't just abstract geology. It's the engine behind volcanoes spewing lava, mountains rising, and yes, those heart-stopping earthquakes. But here's where it gets mysterious. And this is the tease that hooks me every time. How does a shift way out in the Pacific trigger quakes thousands of miles away? It's not like the plates are isolated. They're all linked in this global dance. When the Pacific Plate moves, it doesn't just affect its immediate neighbors. Through something called stress transfer, the energy released or built up can propagate, influencing faults far afield. Think of it like tugging on a spider web. One vibration ripples out, potentially setting off another strand. We'll unpack that more. But first, let's appreciate the sheer unrest of this giant. The Pacific Plate is the heart of the Ring of Fire, that horseshoe-shaped belt of fury encircling the ocean basin. This isn't hyperbole. About 90% of the world's earthquakes happen here, and 75% of active volcanoes call it home. Why? Because the plate's edges are battlegrounds. On the western side, it's subducting under Asia and the Philippines, creating deep trenches like the Mariana, the deepest spot on Earth at over 10 kilometers down. As it plunges into the mantle, it melts, feeding volcanic arcs from Japan to Indonesia. To the east, it's grinding against North and South America, birthing the Andes and the Cascades. And in the south, it's diverging from the Antarctic plate, quietly building new crust. This constant motion isn't peaceful. Take subduction. The Pacific Plate, being denser, sinks under lighter continental plates at rates of 5 to 10 centimeters a year, but it sticks and strains until, snap, a megathrust quake unleashes hell. Remember the 2011 Tohoku quake in Japan? That was the Pacific Plate lurching, killing thousands and triggering a tsunami that crossed the ocean. Or the 1960 Valdivia quake in Chile, the strongest ever recorded at 9.5 magnitude. Again, Pacific Plate subduction at work. These aren't one-offs. They're symptoms of the plate's relentless push. But let's talk recent unrest, because as of September 2025, the Pacific Plate's been making headlines. Just this July, a monster 8.8 magnitude quake struck off Kamchatka Peninsula in Russia, right where the Pacific Plate subducts under the North American plate. It was the sixth strongest ever recorded, sending tsunami warnings across the Pacific and aftershocks rippling for weeks. Scientists say it happened on a megathrust fault, with the plate moving about 80 millimeters a year there. Barely 10 days earlier, a 7.4 foreshock hit nearby, hinting at building stress. And in early August, a 6.4 quake rocked the Pacific-Antarctic ridge, where the plate's diverging. These events aren't random. They're the plate's way of releasing pent-up energy from its non-stop motion. Now, friend, here's the mind-bender. These Pacific shenanigans don't stay local. Enter Coulomb stress transfer, a fancy term for how one quake's slip changes stress on nearby or even distant faults. When a fault ruptures, it relieves stress there but can increase it elsewhere, like squeezing a balloon and watching it bulge out. Small changes, even tenths of a bar, that's like atmospheric pressure, can nudge a fault closer to failure. Studies show aftershocks cluster where stress jumps and rates drop where it falls. But globally, it's subtler but real. For instance, big Pacific quakes can trigger microseisms or even moderate events worldwide through dynamic stress waves, those seismic waves that travel the globe. The 2004 Sumatra quake on the edge of the Pacific system triggered swarms in Alaska, thousands of miles away. And stress models show how sequences propagate. The 1992 Landers quake in California, Pacific North American boundary, loaded stress on the site of the later Hector Mine quake. Scaling up, the Pacific Plate's subduction drives the whole system's dynamics. Its fast sink pulls on adjacent plates like the Nazca or Juan de Fuca, influencing quakes from Peru to Washington state. Think about the North Anatolian Fault in Turkey, far from the Pacific, right? But historical sequences there show stress transfer chaining quakes along the fault, much like how Pacific Ring events might indirectly stress global hotspots via mantle flow or plate coupling. Or consider intraplate quakes, like those in Tibet or Africa, where distant plate boundary stresses accumulate. The Pacific's dominance, carrying most of Earth's subduction, means its unrest tweaks the global stress budget. Climate ties in too, adding another layer. Glacial melt or heavy rains can alter stress loads, potentially triggering quakes. In the Himalayas, monsoons unload stress, reducing microquakes, while dry seasons ramp them up. With climate change accelerating ice loss in places like Greenland, near Pacific influences via plate motions, we might see more glacial quakes. Even groundwater pumping in California's Central Valley stresses the San Andreas, a Pacific boundary fault. It's all connected. The Pacific's heat-driven motion links to atmospheric changes above. But let's not fearmonger. This knowledge empowers us. Models using stress transfer forecast hazards better. After Kobe in 1995, stress maps predicted aftershock zones accurately. In the Pacific Northwest, the Cascadia subduction zone, where Juan de Fuca, a Pacific fragment, dives under North America, is overdue for a big one based on stress buildup. Recent Kamchatka events remind us, monitor, prepare, build resilient. Wrapping this up, the Pacific Plate isn't just a local troublemaker. It's the conductor of Earth's seismic symphony. Its size, speed, and boundaries forge connections that span oceans, influencing quakes from Alaska to Antarctica and beyond through stress ripples and plate interplay. Next time the ground shakes, remember, it's one planet, one web. Stay curious, stay safe, and let's keep unraveling these mysteries together.